Okay, so we are going to be doing related rates today. This is going to be a 2-day lesson.
So homework today or no?
I posted the homework. It is not due until Monday.
Monday?
And it is 5 problems. 2 of them are multiple choice and 3 are open answer.
Oh shoot, you want this one?
I don't like
visual assignments because I feel like the questions are going to be like.
Well, the 2 multiple choice ones are AP questions.
Oh, well, we're all going to work together on this, okay?
It's fine. Homework.
Just going to say that I strongly prefer Dr. Palmer over. And like, she just actually says what we need to learn instead of me having to decipher her. So by the way, and then talks for 5 minutes, and that's
No.
I didn't. She's talking about how she got confused on Facebook. Well, they have Black family and like the Black Lives Matter thing. I'm like, please.
I don't want to defend Kennedy, but I also don't think it was meant towards Black Lives Matter. I meant more towards the family part.
Or the fact that she's like, I'm sure she made it.
Really like bad moments.
Yeah, that's bad.
I don't know. It's kind of weird.
Oh, does it appear that way? We have like making jobs in every class.
Oh,
She's like, I'm pretty sure you switch up every class I have. I'm like, it's
not
not
that
that
deep.
deep. I don't think he cares that much.
The whole conversation is going to be recorded for you to reflect back on.
Oh no!
I don't think anyone wants. Maybe Mr. Barnes has to watch it.
Hey, I'm still riding it down. I'm riding it down. That's how we do it. I'm sure you guys.
Kennedy's in his office. I know.
Yeah, I don't like that.
Okay, so problem number 1. Suppose a circular skin infection spreads with radius increasing at a rate of 0.3 inches per day. Find the rate at which the area of the infection is increasing at the time when the radius reaches 1.8.
What? Kind of skin.
Wait, find the rate.
Yeah, we're looking for a rate here.
Rate of change.
0.3. That's the radius. It says increasing the same. But that's the radius. The radius is increasing.
Just waiting till we're all done.
Right. You're gonna wait until like you're out of the way.
I know, that's why I moved.
Are the notes posted?
Yes.
Okay. Cause like I can see it, but like my picture cuts it off.
I can move it.
Voila.
Just match. So the first thing we're gonna do is we're gonna pick out the information that we know from the information in the problem, and then we're going to identify the missing piece of information that we're gonna be solving for. So what is the first thing that I know? The rate at which the radius is increasing. So we call that dr dt.
Oh,
So the rate at which the radius is changing over time. And that is a rate of 0.3 inches per day. What else do I know? I know that I am looking to see how the area is increasing when the radius is 1.8 inches. So yes, I do know my radius measure here. So R is going to be equal to 1.8 inches. And then what am I going to be solving for or finding for this problem? The rate at which the area is changing in terms of time. So that's going to be dA dt. And that is my unknown. So I'm going to put a question mark next to that, which means I have solved my problem when I have found this rate of change for the area. So I'm sorry, what? Okay. So if I'm trying to find the rate of change for the area, I first have to have my area equation. So what is the area of a circle? Pi r squared.
oh, that was right.
Yeah. So my area is equal to pi r squared. Since I'm trying to find the rate of change for my area, once I have my equation down to one variable, I'm going to derive or differentiate this equation. So the derivative of A is going to turn into dA dt. Oh wait, sorry, dA dr, I said that wrong. Equals, what's the derivative of pi r squared? 2 pi r, and then dr dt, because I took the derivative of r. We're kind of okay there. Kind of.
Why you would use the derivative with respect to place the R using it.
I didn't take an r out, I differentiated.
Why?
Because when I differentiate my radius, it's in terms of time. The more you do it, the easier it gets. Kind of. Okay, do I know dr dt here? Yes. Do I know my radius here? Yes. So then I take that information and I fill it in and I solve for that. So when I do, I get 2 pi times 1.8 times 0.3. And I can just put all of that into my calculator. Remember the pi button is?
You know what the pi button? Yeah. Oh. Yeah, I had a Casio.
He had a Casio. Now he's on the correct technology
I prefer Casio.
because you're used to Casio. Okay, what did we get?
3.
Approximately, because these are rounded numbers.
I think he was just really trying to say that.
And then we have to have, that's what I got to, but then we have to have a unit. So area is inches squared, and then my time is per day. So this is how the area of my skin infection is changing in terms of time. That's the area.
What about the DA?
Well, That's what, yeah, it's DADT, because I went from radius and radius went to time.
DA over DR.
How
Yeah.
is that the
Because that was my, variable over here, but then radius was in terms of time.
Hold on. If we're supposed to find DA over DC, then how is DA?
We did find DA over DT, because this was in terms of R, but R was in terms of time. So it still works out the same way. Homework is assigned not due tomorrow, due Monday. And there will be some partner time, is my plan.
Today? No. Okay, good.
Either tomorrow or Monday. Or both, I don't know. This is difficult.
Do we have a partner section of the ED test?
No.
Bruh, I need this help more than
Okay, next problem.
I need anybody.
He doesn't even get a choice.
No. He would help.
I just suddenly thought of it like speed dating and Liam, and then you have to move on.
This is number 2, right?
Yes, ma'am.
Wait, how many examples?
There are 8 altogether. We're not going to get through all today. Problem number 2. The side of the square is increasing at a rate of 6 centimeters per second. Find the rate at which the area of the square is changing at the time when the side length is 20 centimeters. We'll try to get through 4 today. Oh my God.
Besides the square side of mine. I don't know, it's sure about who's gonna write it.
Turn your mic off, buddy.
Rip it into her.
Well, what is she doing?
I can mute her, but then I'm afraid she's gonna start talking and not know that she's muted.
Aaron,
What?
being like ice or something.
It is ice.
It is ice.
I knew it was. Aaron, just turn your mic off unless you need it.
Oh, sorry. Sorry.
You guys are being so mean to her. She sounds so sad.
Aaron, I love you. Do what you want. Don't
She's
you
literally
ice.
getting so mad at me right now.
I'm not. Just frustrated. I'm not agreeing. I'm just talking on ice.
She's hydrating. It's fine. Okay, just like before, we need to pull out the information that we know and then find the information that we're going to be solving for. So what's the first piece of information that I get from this problem? The rate at which what is changing? The side of the square. So that's going to be ds dt. So the rate at which the side is changing in terms of time.
I think she's just taking whatever is changing and putting it next to B and then over.
It is. It's always d something over d something. So side in terms of time makes it ds over dt, and it is 6 centimeters per second. It's going
Now
down.
was the last one R because it's rate?
It was radius, but yes.
Okay.
Okay, so what other piece of information do I have? Or what piece of information will I be solving for? I have the side length, right? It tells me my side length is 20 centimeters, so that's S.
We have a,
Do I have the area or am I solving for the rate at which the area is changing? What do you guys think?
but we can find the area, right?
What do you guys think? What am I solving for? The rate at which the area is changing in terms of time. So dA over dt
Is what we're solving.
is what we're solving for. So that's my question mark. So if I'm solving for the rate at which the area is changing, I have to have an area equation. So if I'm talking about a square with a side of S, what is the area of my square? S squared. Because it's length times width, but length and width are the same. Everyone okay there? This is down to one variable on the right-hand side, so I can go ahead and differentiate this. So when I differentiate the area A, that turns into dA ds. It's S because I had an S variable on the right-hand side. What's the derivative of S squared? 2s, but since I took the derivative of s, I also have to indicate that I took the derivative of s by writing it as ds dt, which says I took the derivative of s in terms of time, because that's how it was given to me.
At this point, I understand that you're supposed to plug everything.
So you know the process, but it's the notation.
No, it's like
Or-
getting to this, like, I understand that right now where we are, we need to plug in this one, we need to plug in this, and that's how we find it.
Right.
But I don't understand how you got to this point.
Okay, do you understand how I got an area equation?
Yes.
Okay, so I implicit differentiated this, but instead of putting a y prime or an r prime or a t prime, I'm writing the other notation. So when I took the derivative of a, I had to indicate that I took the derivative of a by saying I took the derivative of a in terms of s, because that's my variable. Then when I took the derivative of s, I took the derivative of s in terms of time, because that's what I'm always taking the derivative of that in terms of. Well, sometimes you just need to see it or hear it differently. I get that. So now, as Deanna already pointed out, I can fill in the given information that I have, because I know what my side length is, and I know how my side is changing in terms of time. So I fill that in, and then I'm done. So when I do, I get 2 times 20 times 6,
Use 240
which is 240 what?
squared.
Centimeters squared per second.
Per second. Yep.
Yeah, it's not.
Because area is always our unit squared, and our time was per sec. It was seconds for our units.
So like, figured out that you could just take a derivative of a bunch of numbers and then like equal out these things. Figure out too much time on their hands.
Where does this apply?
Nowhere.
In general life, absolutely nowhere. I mean, literally nowhere.
Well, whenever I make my squares, I have them increasing. Degrees, and this would apply.
Well, this could apply, like if you're an engineer and you're building a building on a certain type of material that expands at a certain rate or decreases by a certain rate based on the weather, this would come in handy there. Because you have to allow for that expansion, even of the materials that you're building with, to make sure that it doesn't disrupt the foundation of your building.
You know, like wood and steel.
But in
Where will this apply if I have high refraction?
absolutely nowhere.
Okay.
I want to be
Well, I guess you could use this to calculate how
How much their spine.
body material expands or condenses during exercise, or I don't know. I'm sure I can think of something. Just give me a little bit.
That doesn't sound like a specific training.
It could be, depending on the person. There's probably a calculation for that. And the rate would vary, of course, depending on the person and body mass. But okay, questions, concerns, or issues on this one? Is this maybe starting to make a little more sense?
Yes, actually. maybe
Okay.
a little.
Let's do another one.
Barely, but like.
I think the worst part about these is you making us write out 5 paragraphs.
You think I enjoyed it? Because I didn't. I can
It's
tell
like
you that
But you're still making us do it.
right now.
I think I just saw the next one. It looked really long.
It's a little bit longer than the last one.
Of course.
Well, the last ones are pretty long. Also writes really.
Do you want me to write smaller? Because I will.
No, I mean on your paper.
Oh. I don't get it. Oh.
Like when they like announce them at basketball that year, I swear they. Oh, really? Like,
There's a dude on Culver that was.
Oh, wait. Do they do that if you're really short too?
no, they do it for everyone, so it's
They just-
more intimidating.
They see that Owens 5.
See, I think it'd be kind of funny if you have like a 5'10" person, you see they're 5'7". So the team is like, yeah, and then they get out there and they're taller than they think.
That would seem more
Yeah, that's
intimidating.
more.
Right? That's what I'm thinking.
Like more intimidating.
I just
Oh
remember
my
them
God.
announcing like Remy, and then they're always like 6'1", but I was like, is she really 6'1"? Oh,
Like, I'd definitely be like, are you sure? 6'3"?
I feel like, hold on, let me get.
Because then once I see them, I'd be less intimidated. I'd be, oh, they're not really 6 foot. They're like
We should get that guy from TikTok who takes like a picture of a person holding an
And
object and it
finds
calculates their height.
I don't know how he does that. I don't even think he's right. I think everyone just believes him because like he says it with confidence.
What some of the people like reply,
Like, do this.
Yeah, I mean, it's not like too hard, I guess.
If we had enough time to like calculate the speed at which the ladder is falling away from the house, I think we could have stopped it falling.
maybe that's not my goal.
Why not? Is there someone on the ladder or not?
Maybe. Maybe we don't like them.
Is Jeff on the
Is
ladder?
it Jeff? For some reason, I'm thinking triangles, like Pythagorean theorem.
Keep that in mind.
This feels
Ah,
like
done.
one of my English essays.
This takes me like the journal you had to do. Like that was the problem. The entire paragraph.
Yeah.
I hated it. I hated that.
So far, we've taken notes.
I didn't know, it's not even real.
Yeah.
That's it.
The word.
It's English, but, yeah. And then I have the she was asking us like questions about the time she was my daughter.
Yeah, you guys were doing this. I think he was. He was.
Are we all ready?
No. Do you know why they didn't let us out?
That's happened multiple times. this year.
I don't think, like every time someone's like, "Are you like, okay, no, it's a senior."
Because Heidi has one, there's another girl who's more than. You have a bunch of them.
Someone had one like. It was.
I have her in class though during that time, and she didn't like give a text or anything. Normally she does. So that's why I don't think it was that.
I know her.
Social anxiety.
I have anxiety. I don't have it.
Okay, a 34-foot ladder was placed against the side of a house. The ladder began sliding away from the base of the house at a constant rate of 2 feet per second. At what rate was the top of the ladder moving toward the ground when the base of the ladder was 16 feet away from the house?
Sorry.
Well, it's something
on top of that
over
ladder, it's faster than 2 feet a second.
Why you always? He's like, "Are you couch?" You can ask him that. Like this
That
little
is
pop.
flat.
D
It is.
L over T like length,
Okay.
or D H like height.
So on this one, we kind of have two variables going on. So I suggest drawing a picture when you have more than one variable that you have to account for. So when I'm drawing a picture here, I have the house, I have the ladder, and I have the bottom of the ladder, right? From here, I can go ahead and fill in any information that I have about this, such as what is the height of my ladder? Do I know it?
Yeah, 34.
34. So I know that that's my hypotenuse of this right triangle. From there, I kind of just need to identify variables that represent the height that the top of the ladder is from the ground, and then the distance from the house that the base of the ladder is.
It says it's 16.
Right, but I'm still gonna need a variable for it. I'll show you in a second.
Why don't you assume it's the right time?
Well, if I have a house, hopefully my house is perpendicular to the ground. And then any ladder leaning against that, we're going to assume the ground is fairly flat. Otherwise, it's not safe to operate a ladder.
Well, if I'm falling, probably.
That could be. That is unknown to me, so I assume that it's flat ground.
Except I don't know.
Now, how are we saying this?
No, it says as the base slides away from the house. So it's got to be falling like this.
Well, then that's 16 feet at a constant rate, though, wouldn't it?
Maybe it is on a hill, but it's actually sliding this way.
It's actually on, someone put on a skateboard. It's actually.
Well, it says sliding away from the base of a house, so it still has to be going in that direction. Just saying. We've kind of covered this. Anywho.
But it says the base
Maybe the AC test.
Yes, it does. We're gonna fill that piece of information in, I promise. So we're going to say that this height of the top of the ladder from the ground is gonna be represented with Y. And then the distance from the house that the base of my ladder is, we'll say is X, okay? I know that the base of my ladder is how far away from my house? 16, so X here will be equal to 16. I know that. Do I know anything else about either the height of the top of my ladder from the ground or the base of my ladder from the house?
34
What is?
squared root of 6.
Height.
The height of the top of the ladder is changing how?
There's a lot of words in this paragraph.
I know there are, so I need you to pick out the important ones.
With the height of the ladder.
That's what you're telling me.
But it says sliding away.
Okay. Is it the base that we know the rate of change of, or is it the height that we know the rate of change of?
Base, 'cause the top of it is
Okay,
sliding away.
so that would be dx dt down here. Because I know the rate of change at which my base is sliding away from the house in terms of time is equal to what? 2. I know it's a positive rate of change because it's sliding away from the house. If it was sliding toward the house, it would be a negative 2.
Do we put
Yes, it
for a
would.
second there?
Yes, we're gonna put it for a second. Okay, pause.
Yeah.
We're gonna pause so we can clarify any issues you guys are having so far.
Even if we move towards it, we're just on Earth and it's still moving in the direction like.
Yes, but it would be the distance from the house would be decreasing, which is why my rate would be negative. Right now, my distance from the house is increasing because it's sliding away, which is why my rate is positive.
Yeah, so
It
why
also
is
says
it,
sliding away.
Yeah.
why is X just a fixed value then, since it's sliding away when X technically be getting longer?
Yeah, which is why it's increasing. But I know that at a specific point, it's 16 feet away, which is why X is a constant.
Okay.
Any other questions? Are we okay with the information we filled in?
So far.
What am I solving for?
Why? No.
The rate at which the top of the ladder was moving, which is my y variable here. So I'm solving for dy dt. Because it's the rate at which the top of my ladder's height is changing. That's going to be my unknown. And that's what I'm going to be solving for here. Do I have all the information that I'm going to need to solve this?
I don't think so. Like, I do.
Say it again, Shepard. I don't know what y is. I can't solve for dy dt unless I know what y is. So I will use the Pythagorean theorem to solve for what my y value is when the base of my ladder is 16 feet from the house and my hypotenuse is 34. So we're going to have y squared plus 16 squared equals 34 squared. And then you guys are going to solve for y. Other people have.
They have it until you were right. We already did.
You already did it? Everybody else do it too. Okay, so I do end up with the fact that y is 30 here, which is awesome, but that's still not answering the question that I'm trying to ask.
Area.
No, the rate at which my y is changing as the ladder falls.
But I don't need the area.
Why would the house be changing?
It would not be the 30 minus that because I have to have some sort of equation that I then take the derivative of to find this. So what's the only equation I can think of when it comes to this right triangle? The Pythagorean theorem is what I'm going to be differentiating. So my base Pythagorean theorem is x squared plus y squared equals what? The 34 squared. I know that equation. Well, not a, because it's not an area.
No, but when you do Pythagorean theorem.
Right, a squared and b squared equals c squared. But I had a value for c. I'm not filling in the values for x or y yet because I want those variables to stay through the differentiation process, and then I will fill them in. So since I have this, I'm going to go ahead and take the derivative here. What's the derivative of x squared?
2x. Well, in what way?
And then dx dt, because I took the derivative of x. So I have 2x dx dt, which means when I take the derivative of y, I'm going to have 2y dy dt. And then what's the derivative of 34 squared? 0, because it's a constant number.
Are we looking for dy?
Yes, we're going to be looking for dy dt here.
So do we subtract?
I'm going to give everybody else a chance, and then we will come back together. Okay, so does everybody understand? I just took the derivative of x squared, and I had to show that I took the derivative of it, so that's where the dx dt came in. I took the derivative of y squared, so I had to show that I took the derivative by using dy dt, and then the derivative of a number is just 0. Anybody super confused there? My end goal is to solve for dy dt, so I need to fill in all the other information that I currently have. I have everything except dy dt. So I start filling it in. And it becomes 2 times my x value of 16 times dx dt, which is 2, plus 2 times my y value of 30 times dy dt equals 0. And then I will use basic algebraic manipulation to get the dy dt by itself.
The x is a constant. Oh,
It doesn't have to be a constant because I know what it is at the specific point. That's why I was able to fill it in. So when I do my basic algebraic manipulation, I end up with 64 plus 60 dy dt equals 0. I move the 64 over, and then I divide by 60, and I get the dy dt is equal to negative 64 over 60. For rates of change like this, it is entirely okay for you to give me the decimal to 4 decimal places. So what would be my rate of change for the top of that ladder? Negative 1.0667 what? What are my units? Feet per second. Nope, just feet. It's only squared if I'm talking about area, and then it's cubed if I'm talking about volume. And that makes sense because I know the top of the ladder is dropping, so the distance from the ground is decreasing, which is why my rate is negative.
I didn't like that one as much.
How do we feel about this one?
It sucks, but
It's all right.
Not the worst thing?
This one was the most confusing.
Yes.
it's kind of like the optimization where we have to like figure out the, yeah.
It's very similar to optimization in that way, yes. Okay, so this next one is the last one that we're gonna do today because I don't want to overwhelm your brains. And this one is truly my favorite because it's most applicable to real life.
Is it short or long?
We have 4 minutes. Can I run over into SRT a little bit for you guys?
No.
Just for this one problem.
If we get everyone else to shut up.
I will. Okay. This problem is really short. It's only this on my notes. Like,
She said it's really short.
But it's over.
for the record, we would have been fine if we hadn't had a holdover in the other class.
Why can't they tell you what the holdover? I feel like.
I don't know. And they might later on, but not right now.
I definitely left my house last night and there was like a drug search going on right outside.
Nice.
Outside of your house.
No.
No, like there was a car pulled right outside my house. They were like searching the car. And she looked like a target.
So it says Pete is 6 feet tall. As he walks away from a 42-foot lamppost, the length of his shadow is increasing at a rate of 1.5 feet per second. At what rate is he walking away from the post? Or in other words, at what rate is his distance from the post changing?
That party, oh.
We have to draw a picture.
We will draw a picture. We're all done writing.
Stop. Middle of a word several times.
I don't like when I do that. Okay, so the first thing we're gonna draw is this lamp post that Pete is walking away from. That's my lamp post. I know that Pete is some distance away from that lamp post, and I know that he's walking away from it, and that his shadow is changing.
Shouldn't it be?
What is this starting to look like to you?
Not a triangle.
a right triangle,
On a line.
in theory.
Two.
Two right triangles that also form one right triangle. Since we've identified that this is a right triangle, I can go ahead and start filling in any information that I currently have about it. So the first part is, this is my lamppost and it is how tall? 42. I know this little person right here is Pete. How tall is Pete? 6. What do I know that this is in regards to Pete? Just take a seat, Grant.
That's ridiculously tall.
Hold on. What is this little piece right here? It's a shadow. Do I know anything about that shadow?
Oh.
It's changing at what? Sorry? 1.5 what?
I don't know that.
Ow, the trash can.
Okay, as you're coming in, you'll be silent. Find a seat. You guys can go. And be quiet. Do I have any other information?
So is he walking away from it?
I know that this distance x is the distance he is from that lamppost,
So hard.
right? I love this one. This one's so much fun.
I don't ever walk away from a lamppost and wonder how big my shadow is.
Okay.
You walk at varying speeds to make sure that your sound. That's
Oh, I do. And if the lamppost is on, it's dark outside, and it's not.
I have a question for you since we failed. I really do want to get through this as much as you do. So I do have a question because we failed to recognize what this is. What is this 1.5 feet per second? The distance, or not the distance, the rate at which his shadow is increasing per time. So this is ds dt, which my shadow is changing, which means that s right here is the length of my shadow. If x is the distance that Pete is from the lamppost, what am I missing in that section? Or what am I going to be trying to find?
dx dt.
dx dt. How did you know that, Aaron?
I looked at the notes.
Right. But what is dx dt?
Well, it has the x value right there, so.
Well, x is the distance that Pete is from the lamppost. So what is dx dt? The rate at which he is moving away from the lamppost, which is what this is asking me to find anyway. So that dx dt is what I'm going to be looking for. So I don't really have a super awesome equation to go with this, which means I'm going to have to use something else in my, I don't know, backpack of math skills. And that is the proportionality of similar triangles. So proportional sides on similar triangles, or same sides on similar triangles, are proportional to each other, which means the base of this triangle, which is our 42, over the base of my smaller triangle is proportional. That also means that the longer leg on my smaller triangle, which is S, is proportional to the longer leg on my larger triangle, which is X plus S. So we're using the knowledge that similar triangles have like sides that are proportional to each other. I know. Does everybody understand how I set that up? So the X plus the S is the length of this entire base side. S is just the length of the base side on my smaller triangle. And then 42 and 6 were the heights of each of these individual similar triangles. Are we okay with that?
Wait, you're not done, are you?
I'm not done. No.
So 7.
What am I going to do now?
Can you fill in?
Nope, can't fill in anything right now
Not that.
because I have no information. Not yet. At this point, if I have to take the derivative, I'm using quotient rule, and that is exhausting to me.
Take the S on the top.
Cross, multiply, get it all to one level. Did you say that and I just missed it? Lauren did? I'm so sorry. Okay. So we cross multiply this bad boy. When we do, we get 42S equals 6S. 6x, sorry, plus 6s. Then what can I do? Subtract the s, right?
Good morning, KHS. Here are your announcements for today, January 7th. The last day to order caps and gowns and other senior items is Tuesday, January 12th.
Nope.
Orders have been sent in order to get through the process. If you have
Say it again.
Derivative.
Derivative.
S equals.
Because I'm going to be solving for dx dt, so I have to have the dx dt that I can solve. So I'm going to need to differentiate this. When I differentiate the 36s, it becomes 36 ds dt. When I differentiate the 6x, I get 6 dx dt.
The Next Generation Hoosiers Educator Scholarship provides 205 students high school students in career and education.
Do I know ds dt?
Scholarships.
It is the 1.5 at which my shadow's length was increasing. So I go ahead and I fill that in.
Where did you get 36?
42 minus 6.
That checks out.
Thanks. So I fill that in. I get 36 times 1.5 equals 6 times dx dt. Of course, I will simplify it out by multiplying 36 by 1.5, then I'll divide by 6. And what do we get the dx dt is equal to? Say it again. 9 what? Feet per second. So the distance at which Pete is walking away from my lamppost is at a rate of 9 feet per second. How do we like that?
I feel brain-dead.
Okay. So of course we're gonna stop here. We're out of time anyway. But the homework is on Canvas and you can definitely do some of them. We'll finish up the last 4 examples tomorrow during class. There are 5 on the homework.